Okay, in this video we are going to continue our discussion of radicals, but in this specific one we're going to simplify radical expressions. So I guess similar to something like 2x times 3x, and to simplify that we multiply and get 6x squared. We'll do similar things. We'll combine things or re-express things. But this time we're using radicals or irrational numbers, or typically we're using square roots, but you could have to be ready for cube roots too. So this is the main rule that we're going to use through this whole scribblecast, and that's called the product rule. And it basically says is if you take the square root of a product of two things, then that's the same thing as taking the square root of each one of those factors separately. Conversely, you could take the square root of x times the square root of y, and then rather than having two square roots, you can rewrite that as the square root of the product of those two things. So here's another example. Square root of 2 times square root of 3 is the same thing as the square root of 2 times 3. And in this case, I could multiply those. 2 times 3 is 6. So this and this and this are the same. And that's the product rule. Here's another example, square root of 15. Well, that's the same thing as the square root of 3 times 5. And since I'm multiplying, or a product inside, I could take the square root of each one of those separately. Okay, so product rule. And I'm just going to go through a barrage of questions where you can see, sorry for the microphone there, so where you can see this product rule in action. Okay, here's one. Square root of 16 times square root of 25 is the same thing as the square root of 16 times 25. Or 16 times 25, I think, is about 400. I'm hoping. Oh, and the square root of 400 is actually equal to 20. So there's the product rule in action. Now, you probably could have looked at it and said, hey, well, Jeff, the square root of 16 is 4, and the square root of 25 is 5, and 4 times 5 is also equal to 20. So yeah, it's you can do things in multiple ways as long as you are following the rules that have been outlined. Here's another one. Square root of 6 times 3 is the same thing as the square root of 6 times 3. And I could rewrite that as whatever 6 times 3 is equal to. And then with this particular one, I could keep simplifying. But I'm going to show you that in another slide or two. That I could change that, but I just wanted to show you that product rule. Here's a couple more. Square root of x times the square root of x minus 4 is the square root of the product of those two things. So the product of x times x take away 4. And I guess I could leave it like that, or if I wanted to use the distributive property, I could write that as the square root of x squared minus 4x. Okay, there's another one. You can do this the same rule works with fractions, so this would be the square root of 4/5 times 5/6, or the square root of 20 over 30. Looks like I could probably simplify that, eh? So that's equal to the square root of, if I divide 10 on both sides, that would be, maybe let me just separate that out a little bit. So that would be the same thing as the square root of 2 times 10 over 3 times 10. And following similar rules, I could write that as the square root of 2/3 times 10 over 10. Or the square root of 2/3 times 1, right? And 2/3 times 1 is, of course, just 2/3. You could have simplified that probably right off the bat if you wanted to, like the 5 and the 5, that's a factor of 1. 2 goes into 4 twice, 2 goes into 6 3 times, and I would have come up with the same answer. Okay, but I'm using that product rule. Let's try it in a couple of different places. So here's the square root of 32. They want me to simplify that. Well, I'm thinking, okay, that to simplify, what numbers could I use to multiply that? And maybe, as we're reading up here, if you want to simplify a radical, you have to make sure that there are no perfect squares left under the radical. And by perfect squares, I mean a number that is the product of another number and itself. Like here, 2 times 2 is 4, 3 times 3 is 9. Any of these numbers here are referred to as those perfect squares. Or terms such as x squared. That's a perfect square because it's x multiplied by itself. So what I want to do when I simplify square root of 32 is I want to look to see if one of these numbers divides evenly into 32. And typically I want to use the biggest one. I think 16 does. So square root of 32 is the same thing as the square root of 16 times 2. Or, according to the product rule, I could write that as the square root of 16 multiplied by the square root of 2. But I know the square root of 16 is one of those perfect numbers, so the square root of 16 is just 4, and the square root of 2 is not on my list there, and so I guess I'm stuck with that. So root 32 is the same thing as 4 times the square root of 2. Maybe try that with 91 and see what you come up with. I'll try it. 92. I wonder if 4 goes into that. So 92 divided by 4 goes twice 3. Yeah, it works. 4 times 23. So root of 92 is the same thing as the square root of 4 times 23, or product rule, square root of 4 times the square root of 23, but the square root of 4 is 2. Root 23 I can't simplify anymore. None of those perfect numbers will go into there. So that would be my simplification of that one. Let's try some more. Ooh, ones with letters in them. That's good. So 45. Down my list, 9 goes into it. Let's use 9. So I'm going to rewrite this as the square root of 9 times 5 times p cubed. And I could rewrite that as the square root of 9 times the square root of 5 times the square root of p cubed. Now this p cubed we'll deal with in a second, but the square root of 9 is 3. So I have 3 root 5, and then this p cubed. Maybe I could rewrite that as the square root of p squared, which would be a perfect square, right, times p. Or that would be 3 root 5 times the square root of p squared times the square root of p. Do you see how I broke those up? Just like I did with the 9 and 5. Same kind of thing. It's just if I have a square root, the perfect square ones, there's always going to be an even number. But it's p cubed, so I had to separate it into 2 factors that when they multiply, they give me p cubed. Okay, keep simplifying over here. The square root of p squared, we saw in that last video, the square and the square root cancel. So that's just p. So this would be 3 root 5, a p, and a root p. Now, if both of those things are still under the root, it makes sense to combine them. So watch how I reorganize this, and it's the commutative property. It doesn't matter what order things are if you're multiplying. So I'm going to take the 3 and the p, those numbers that are outside of a radical, and put them together. So 3 times p. And then I'm going to take the square root of the 2 things that are still in the square root. So it would be 5p. And that would be the simplification of that one. Try 288p. See what you come up with. Okay, if I was doing that, I think 144. 288 is double 144. So I can write this as the square root of 144 times 2 times p. Now p doesn't have any buddies with it, and so I can't take that out of the square root sign. But this one I can. So it'll be the square root of 144 times the square root of 2 and p. I'll leave p in there because neither of those are perfect squares, so I can't take them out. I'll just take the one out that is a perfect square. Okay, the square root of 144 is 12 root 2p. Okay, make sure you put that line right over top of the p so we know that the p is still underneath the square root sign. Here's a couple more. Square root of 64x. Ooh, this one looks nice. So square root of 64. Maybe let me show you one other way you could think of doing these ones. You don't have to, but sometimes it helps some people. I'll maybe show it on the next slide too. So square root of 68, square root of 64 is 8 times 8 times, and then there'll be 4 x's. 1, 2, 3, 4. Now, with square roots, if it's square root, it means two identical things must be inside. And if there's two inside the same, I can take one out. So here's 2/8. I can take one out of the square root sign. Here's 2x's. I can take 1x out. Okay, so the 2/8 became 1/8. These 2x's became 1x. And then these 2x's, I could bring another x out. So that would be an x squared. And then, and then there's nothing inside the square root sign. So if there's nothing inside, I don't even need to write it. That's what my eraser's for. So the simplification of this would be 8x squared. Here's another nice one. 4x squared plus 5. It looks like it's that x squared action and number, but I wonder if 4 divides evenly into all of those. Let's try it. So 4 multiplied by, that would be x squared. 4 into that goes, I think, 14 times. Plus 4 into that, I think, goes 49 times. Oh, and this one here I could factor, right? X squared action and number. So square root of 4. And then I'd have two brackets. Two things that multiply to 49, add to 14. Yeah, you're right. 7 and a 7. Oh, and they're the same. Imagine that. So this will be the square root of 4 times x plus 7 all squared. Again, I could rewrite this as the square root of 4 times the square root of x plus 7 all squared. Square root of 4 is 2. Square root of x plus 7 all squared, the square and the square root cancel, so that would just be 2, and then x plus 7. And I'd be probably fine there, but they might have you FOIL that out, so it'd be 2x plus 14. Not FOIL out, but use the distributive property. Okay, I think I've got a couple more slides to try. X to the 11th. This one, you're looking for two things identical inside. You can bring one out. So hopefully you're thinking now maybe this is 10. So I could rewrite this as x to the 10th times x, because 10's even, right? Altogether there's still 11 there. But now I see this x to the 10th. That is the same as x to the 5th squared. So I could bring out an x to the 5th out, and I'd be stuck with an x inside. If you wanted to imagine having 11 x's there, and for every 2 inside bringing 1 out, that might help. It turns out you could bring out 5, but you'd still be stuck with 1 x inside. Try this one. Square root of 50r to the 5th. Okay, 50, 25 times 2, and then times r to the 5th. Let me write my 5 r's. There's 5 r's. Square root of 25 is 5, so that could come out. Here's 2 r's. I could bring 1 r out. Another 2 r's. I could bring another r out, so r squared out. And then it looks like I'm going to be stuck with this 2 and this r, still inside the square root sign. So this would be the simplification of that one. One last slide. Let's try these ones. Square root of 2 times square root of 50, product rule. I could multiply those together, so that would be the same thing as the square root of 100. Oh, and the square root of 100, that's one of my pretty numbers, is 10. Lastly, here I've got a product of two things, so I could write it as the product of all of this stuff. So 6 times 6 is 36. X to the 4th and x to the 5th would be x to the 9th. Y to the 1st, y to the 7th would be y to the 8th. Now to simplify, I don't want to have any perfect squares left inside there, so I could rewrite it as a square root of 36 times the square root of x to the 9th times the square root of y to the 8th. If you want, you can write it like that. Typically, hopefully you're thinking of getting two things inside, bring one out. Square root of 36 is 6 times 6. 2 6's inside, bring one out, so that would just be a 6. X to the 9th, I can bring out 8 x's, and when they come out, they have to come out in pairs, right? So pairs of 8, you'd have 4 pairs, and you'd be left with 1 x inside. And then here, y to the 8th, I could bring 4 y's out. So these would be outside of the radical sign. Now this order is probably a little funny. I'd probably rewrite this so that the all the letters outside of the radical are out front, and then the thing in that radical is left out there. Okay, that's just a ream of questions. All of them are using the product rule. And you want to become friends with that and make sure you're okay taking things from two radicals and putting them into one, or if they're in one radical, breaking them out into two, always looking for a perfect square or two things inside the radical where you can bring one out. In future videos, we'll look at things with a cube root. And basically a cube root, it just means if you have three things inside, you can bring one out. Like here, if I had the cube root of x to the fourth, that would be 4x's inside. If I see 3, I can bring 1x out, and I'd be stuck with 1x inside. Oh, and this is a cube root. Okay, try some questions.